147 involves coal being discharged from the tailgate of a dump truck with initial velocity v sub a at this point right here of 2 meters per second at an angle of 50 degrees below the negative x-axis. It wants us to determine the radius of curvature of the trajectory described by the coal at point A and at the point of the trajectory that's 1 meter below point A. I'm calling that point 1 meter below as B. There's the velocity that they have at B, and the velocity is making an angle theta sub B over here with respect to the horizontal, and so that makes this angle right here theta sub B, which is an angle between vertical and perpendicular to the velocity vector. All right, and this is G right here, that's G right there. There's theta sub A, this 50 degrees is theta sub A, and it's going to be the same as this angle right here. This line right here is perpendicular to the velocity vector, and this line is vertical. So to find the coefficient, or excuse me, the radius of curvature, you look in the acceleration formula where in terms of tangential and normal coordinates, where you have A tangential, E tangential, plus A normal, E normal unit vectors. And A normal, if you recall, is V squared over rho. At point A, the A normal is going to be G times cosine theta sub A, because the only acceleration you have at that point is G. So the magnitude of G in the normal direction right there is going to involve cosine of theta. So that's why it's G cosine theta A. That's equal to VA squared over rho A. So rho A then is equal to VA squared divided by G cosine theta A. And that gives you 0.634 meters. That's easy enough to determine. The formula that you would have for the radius of curvature at B is going to be the same type of formula, but you've got to have the velocity of B at that point squared, and then you got to have theta sub B. So we need to find both V sub B and theta sub B. And remembering that theta sub B is the inverse tangent of VBY over VBX. And if you're worried about the sign in there, it's going to be the VBY is going to be a negative component, VBX is going to be a negative component as well, so this still turn out to be plus inside the parentheses. So to calculate VBY, one of the easiest ways to do that is to look at the formula VBY squared equal to the initial velocity squared in the y direction, which is VAY squared, and then minus 2GY, where y itself is minus 1 meter, and VAY, this term right here, is minus 2 meters sine of 50 degrees. It's the component of the y and component of the velocity at A in the y direction. When you plug those numbers in that equation, you get VBY rounded off to be a minus 4.69 meters per second. I kept the unrounded number for future calculations stored in my calculator. VBX is the same as VAX because the x velocity does not change, and that's going to be a 2 meters per second times cosine of 50 degrees with a negative sign because it's in the negative direction. If you throw that into VB squared equals VBX squared plus VBY squared, you got that term right there, you got that term right there, it comes out to be 23.62 meters squared per second squared. Throw the VBY and VBX into the tangent, inverse tangent formula for theta sub B there, and you get 74.7 degrees. And once you know that, then you got VB squared right there, and you got cosine of 74.7 degrees, and you get rho sub B equal then to 9.10 meters.